Hello everyone, myself Dr. Pinal Patel will be discussing about the Newton's third law of motion and law of conservation of momentum. From chapter number 2, force and motion, ન્યૂટનની ગતિનો ત્રીજો નિયમ અને રેખીય વેગમાન સંરક્ષણનો નિયમ from engineering physics. These three laws of Newton laid the foundation for the classical mechanics. ન્યૂટનની ગતિના જે ત્રણ નિયમ છે એ સમજ્યા પછી તમે ક્લાસિકલ મિકેનિક્સ સમજી શકો છો. Basically, these laws describe the relation between a body and the forces acting upon it and its motion. તમે after knowing this, or we can say that this law એ તમને શું સમજાવે છે તો કે બળ કેટલું લગાવો છો તમે પદાર્થ પર અને એ બળ લગાયા બાદ what is happening, that is if it is in motion, ગતિમય થાય છે પદાર્થ, which is nothing but the first law. Basically, first law is defining the force qualitatively. એવું કહી શકાય ન્યૂટનની ગતિનો પહેલો નિયમ બળને કેટલું બળ આપવું પડે છે એ સમજાવે. Second is it explains the quantitative measure of the force. What is the force you will require to accelerate or to bring the body in motion? That is nothing but the second law. The third law says that a single isolated force does not exist. These laws have been expressed in several ways over, I can say, about last 3 centuries. What is the third law, which is very common? Many of you must be knowing this is this equation or this relation or this particular statement. In Gujarati જેને આપણે એવું કહીએ દરેક ક્રિયાબળને હંમેશા સમાન અને વિરુદ્ધ દિશાનું પ્રતિક્રિયા બળ હોય છે. Action and reactions are equal but in opposite direction. In simple, we are saying this. It says that whenever a body exerts a force on a second body, the first body experiences a force that is equal in magnitude. Yes, saman hase, but in opposite direction to the force which it has exerted. That is nothing but the third law of motion, which is very well applied, I can say that, in the rocket engine theory. Yes, this particular diagram itself is saying something, that is the exhaust flow is pushed backward, and because of which the engine pushes forward. Here the body is moving in the opposite direction. What the particular statement means, that in every interaction there is a pair of forces acting on two interacting objects. બળની એક પેર છે જે બે interacting object ઉપર જોવા મળે છે. The size of the force on the first object is equal to the size of the force on the second object. The force છે એ એક પદાર્થ પર equally લાગે છે બીજા પદાર્થ ઉપર. The direction is opposite compared to the first object. The direction of the force on the first object is opposite to the direction of the force on the second object. It moves in the opposite direction, viruddh disha. Forces always come in pairs, equal and opposite, action reaction, force pair. Force pair માં જશે, equal and opposite હશે, yeah, it will be in action and reaction. You can understand this with very simple and I can say easy examples. આના સિવાયના examples भी you can write in your exam. GQ માં ઘણી બધી વખત પૂછાયેલો સવાલ છે કે ન્યૂટનની ગતિનો ત્રીજો નિયમ લખો ને ઉદાહરણ આપીને સમજાવો. Give the third law of Newton and explain it with 2 or 3 examples. Simple, a book placed on a table pushes down on the table and the table pushes up on the book. ટેબલ પર પડેલી બુક તેના વજન જેટલું બળ ટેબલ પર લગાડે છે અને ટેબલ તેટલું જ બળ બુક પર લગાડે છે. That is nothing but the action reaction. Same, you can understand it by the diagram of a swimmer. exerts an action force on the water. The water also exerts an equal force, but in the opposite direction. Yes, તમારું જે reaction force હતો, reaction force is one which I am giving with the hand to the water. Yes, and the swimmer moves forward. પાણીમાં તરતી વખતે તરવૈયા પાણીને પાછળ ધકેલે છે અને પાણી તરવૈયાને આગળ ધકેલે છે. A bullet is a very common example which is fired from the gun. The gun exerts a force on a bullet in the forward direction. This is the action force. The bullet also exerts an equal force on the gun in the backward direction. Same amount of the force is being exerted, but in the reverse direction. This is the reaction force. What was the action? That bullet is firing. And what is the reaction? That is the recoil force of the gun. Due to the large mass of the gun, it moves only a little distance backward by giving a jerk at the shoulder to the gunman. ખભા ઉપર આપણને થોડો જર્ક લાગે છે જો બંદૂક ખભા ઉપર હશે તો. ઓકે, કારણ કે એનું માસ વધારે છે એટલે તમને જર્ક ઓછો લાગે છે. બંદૂકમાંથી ગોળી છોડતી વખતે ગોળી આગળ જાય છે અને બંદૂક પાછળ તરફ ધકેલાય છે. અમે જસ્ટ પોઈન્ટ લખ્યો છે. યુ કેન રાઇટ in your own words and explain the examples in the exam. मैं તમને just ગુજરાતીમાં just I am giving you the hint or point. And હું બોલું તો છું, so you can understand it very well. Rocket moves forward by explaining gas backward at high velocity. This means the rocket exerts a large backward force on the gas in the rocket combustion chamber. Therefore, the gas exerts a large reaction force forward on the rocket. Same, હમણાં જે મેં કીધું કે એમાંથી ગેસ નીકળે છે, that particular, it is nothing but it is an action force, and due to which the rocket is moving up, that is the reaction force on the rocket, that is pushing in the opposite direction. Okay, same way, this is one GIF which I have taken it. You can see the same thing. After firing, when the cannon shot from the cannon ball, it moves backward. Cannon ball આગળ જાય છે અને cannon પાછળ ખસે છે. તોપમાંથી જ્યારે ગોળો આગળ જાય છે તો ફોર્સના કારણે ball is moving in the forward direction, but the same thing, that is the cannon પરનો જે force છે તોપનો, એ તોપ આખું પાછળ ધકેલાય. Okay. What is the law of conservation of momentum? રેખીય વેગમાન સંરક્ષણનો નિયમ. Total momentum before the collision and after the collision on the system is same. अलग करेला तंत्रનું પ્રારંભિક વેગમાન અને અંતિમ વેગમાન અચળ રહે છે. That is constant. अलग करेला તંત્રનું કુલ વેગમાન અચળ રહે છે. The momentum before and after collision remains the same. Total momentum. This is a ball which is moving with some mass and a velocity. The another ball from the opposite direction with some mass and velocity. When they are approaching, there is a collision. After collision, the momentum is same just as the collision before, the momentum before collision. Collision પહેલા એનું જે momentum હતું અને collision પછી જે એનું momentum હતું is same. This we can understand with this mathematical formulation. Same, मैं બે ball या two bodies consider કરી છે, A and B, જેનું mass I am explaining in both the languages. And for the Gujarati medium students, after this slide, you can see the things I have written in Gujarati. There is a body of a different masses, dar એનું M1 and M2. અલગ પ્રકારના દર છે M1 and M2. They are moving in a straight line and in the same direction. Figure B shows that they are colliding for a very short period. ખૂબ ઓછા સમય delta t માટે તે collide થાય છે. After collision, they move with the velocity v1 and v2. Collision પછી અમુક વેગથી તે opposite direction માં ગતિ કરે છે. Force applied by A on B, that is nothing but the rate of change of momentum of B. From Newton's second law of motion, જે આપણને બધાને ખબર છે કે what is the second law? Okay, it is F is equal to m into a, mass into acceleration. What is mass? Okay, if I take the case of force applied on A, B, so it is m2 v2 is the velocity minus m2 u2 upon delta t, that is the time for which they are colliding. કેટલા સમય માટે તે અથડાયા છે. v એનો વેગ છે, u is the initial velocity અને v1 v2 are the velocity after collision. u જે છે એ એનો પ્રારંભિક વેગ છે અને v1 v2 એવું કહી શકાય, અંતિમ ના વાપરું પણ એવું કહી શકાય કોલાઇઝન થયા પછીનો વેગ છે. They are the velocity after collision. Okay, by putting the values I will get FAB is equal to m2v2 minus m2u2 upon delta t. What is similarly, what is the force applied by B on A? So it is m1v1 minus m1u1 upon the time delta t. That is the difference of the. What is the third law? It is saying the action and reactions are equal but in opposite direction. So I have used the negative sign here. FAB is equal to FBA, but as they are in opposite direction, I will use the sign minus. Put the values of FAB and FBA. Delta t will be cancelled. Delta t and delta t will be cancelled. So what will be there? That is m2v2 minus m2u2 is equal to minus of m1v1 plus m1u1. Here, this minus will come here, it will become plus. Arranging the terms, m1u1 plus m2u2, this is the mass of the before collision. u1, u2 શું છે? So they are nothing but the velocities before collision. So this is nothing but I can use the word before momentum before collision is equal to momentum after collision. m1 v1 plus m2 v2. This means the total momentum before collision is equal to the total momentum after collision. Okay. This is nothing but it proves the principle of conservation of linear momentum. Gujarati ma the same thing for the Gujarati medium students. You can write the things in Gujarati, but the terms, that is the definition of the force which we are using from the second law, F is equal to m2v2 minus m2u2 upon delta t. So you have to write it in English only. And at the end you can say that અલગ કરેલા તંત્રનું પ્રારંભિક વેગમાન અને અંતિમ વેગમાન અચળ રહે છે. What are the applications? I have said it before 5-10 minutes. I can say that is nothing but the propelling of the rocket, flight of the jet plane, the system of a gun and a bullet, motion of a rocket and a jet engine. They are nothing but I can say that this use the law of conservation of momentum. Okay, you can, there are many other examples also. You can have it from the internet or Gujarati medium students. મેં કીધું એમ કે હું વિડીયોમાં બોલ્યો એનું તમે ગુજરાતીમાં બી લખી શકો છો. Yes, this, see, I can explain one. The chemical inside the rocket burns and produces the high velocity blast of the hot gases. These gases get ejected downwards with a great velocity. To conserve the total momentum of the gases, the rocket moves up with a large velocity. Just વાંચો તો બી ખ્યાલ પડી જશે કે when the gas is blown out from the rocket, the gas is ejected in the downward direction with a great velocity. But this particular, to conserve the total momentum of the gas, the rocket moves up with a large velocity. Okay. As usual, the questions state and explain Newton's third law of motion with example. એક્ઝામમાં ડાયરેક્ટ એક્ઝામ્પલ લખી દેવાના. ચોપડીનો લખો, સ્વીમરનો લખો, ગનનો લખો. You can write any which you are knowing. ન્યૂટનની ગતિનો ત્રીજો નિયમ લખો અને તેને ઉદાહરણ આપીને સમજાવો. State and give the mathematical explanation of law of conservation of momentum. રેખીય વેગમાન સંરક્ષણનો નિયમ આપો અને તેને સમજાવો. Okay, thank you.